Alright, in today's video we're going to take a look at this microprocessing, to use the Solar Roadways terminology. Smart load. Does have a microcontroller, 16 megahertz at most, this little chip right here. Apart from that, it is using a Darlington transistor, which is this one, and an adjustable voltage regulator, which is the LM317, which you guys might be familiar with. Anyway, I didn't check exactly how they're using them, but I seem to be using them in some sort of cascade fashion for some reason. Then you have some op amps right here. I'm expecting this to be a quad op amp, and this would be a shift register for the display. You can see it going on to the... Holy shit, I just dropped it. So you can see the cabling going to that, and this is the microcontroller. So this has like a shit ton of GPIO pins, the new Voton chip. 16 megahertz at most, so quite swift. 4K of code, plus another 16 or some shit, or another 8. I don't know, they're talking about AP-ROM and LD-ROM and stuff like that. I don't know exactly what that pertains to, but nonetheless it seems to be quite a powerful chip. It's 25 cents in one-off quantities, so also quite affordable. But still quite nice that a load does have it, right? So this is, at the time of recording this video, this load is $10 on AliExpress. This is the official RuiDeng store, right? And they might change the name by the time you watch this video, who knows? But nonetheless, I'll link the product down in the description. So it's $10 for the traditional version, and if you click the other one, so you pay another $2. And this one has a better fan, right? So, and I think it can sync 35 watts. Yeah, so it's 35 instead of 25. So yeah, I'm never gonna sync 25, so I think I'm fine. Although, yeah. All right. So, having a look at the load itself, we have a very nice selection of inputs. So you can connect it obviously into a regular USB port, but it also has a micro USB and Type C inputs, and that is very nice. For example, if you have a little dinky adapter such as this one that you want to characterize, and this one only has this output, or some wire or some shit, and so that is quite nice. What you do have to do though with these, before using them, before ordering them, right, before even thinking about like getting one, before watching this video even, right, so you're already too late. You must put some duct tape over the display, otherwise it is 50 times less readable. It's a pain in the ass. It's absolutely horrible. It should be illegal, right? There should be legislation in place preventing the sale of these displays without any diffusion foil. But yeah, anyway, so once you get that done, it is actually quite readable. So let's actually plug it in, right? So for example, let's use this little USB load. So you can see now it is blinking and flashing a little bit, although let me see if I can help with the flashing. Let's see. No, this is making it worse. Anyway, so it's not actually flashing to the visible eye, to the naked eye. So basically now it is in set mode, so you're setting the current you want it to draw. And there's two buttons which are on, off, and set. I don't know exactly what. Set changes the modes. It should actually be called mode. And on, off turns it on. So basically the moment we turn it on, it should actually overpower this. So it should go off. Let's see. There we go. So it tries, this cuts out, and then kicks back on. So let's go to something a bit more decent, which is 500 milliamps. This is adjustable digitally, right? So this is an analog potentiometer, but the adjustment is digital. So between 0 and 1, you can't actually adjust it. So if you measure it really precisely, it doesn't actually change. So it changes when the display changes, so it is digitally controlled, right? That's probably why they're using the op amps and cascadings and whatnot, right? So let's turn it on, right? So now it is drawing 500 milliamps, and to prove this, I will actually bring another power monitor, a power monitor. Let's actually reset the figures here for OCD reasons. All right. I've made a review of this if anyone's interested. So YZX ZY1276 is the model number. All right. Anyway, so let's plug it in. So on standby, it's drawing, depending on whether the display. Let's actually go to a more. So yeah, 14 or 6 milliamps, right? So 7. So basically just the microcontroller is using 7 milliamps and the display being on another 7, so it's quite decent. It does actually account for this, I think, although I'm not sure. Let's see that again, it's quite new. So yeah, let's start it. And it is quite close, so it is accounting for the drain of the display and the microcontroller itself, so that is very nice. And right now you can actually adjust it live, so let's go to 510, and it's a bit off, right? So it's not ludicrously precise, right? So 510 it should be now. So it's accurate to within 5 milliamps, I'd say, right? And precise to within 10, right? Because you can only set in increments of 10, but it is accurate to within 5 milliamps plus minus, right? So I hope I didn't fuck those terms up. A further reason why this might be a bit less accurate is that it is voltage dependent, right? So I don't know how strong the feedback loop is and how much it depends on it relies on there being 5 volts on the input, because it doesn't actually go down too well, right? So it will give false readings. We'll go into that later. So again, 3 milliamps over, right? Let's go to 10 to 100 milliamps. Again, 5 over, 50. Let's see, 50. Yeah, 50 is bang on. And let's actually use actually something a bit more beefy. All right, so on. So let's go 80. 80 is again 4 below. Let's go 1 amp. 1 amp is 4 below. Let's go 1.5. 1.5 is 2 below, so again we're getting close. So they're probably having some offsets, right, saved in the microcontroller to adjust for different shit, because it is coming really close in some sections, right? So again, 1.8 seems to be bang on. Let's go 2 amps. 2 amps, and it turned on the fan. So 2 amps is actually 10 milliamps over. Let's go 2.5, and this might actually be because my power supply, my battery is not giving a stable 5 volts, right? It does actually go up in some cases. So we're looking at 2.440, so 2.450. So again, actually almost 60, so we're 20 milliamps over now. So yeah, it isn't ludicrously precise, right? But again, as opposed to not having a display at all, right, you would just set it up and use one of these if you want precision, right? And these are just for in cases when you want like a rough idea, right? So you want a battery, you have a battery, you want to discharge it, right? You just set it up 1 amp or 500 milliamps or whatever. You don't care about the 5 milliamps. So this is how I would use it, and I plan on using it, right? Which is very, very nice. Before I would have to plug in one of these, squelch it up, and then plug it alone or not, or it's very convenient. Anyway, so 2.4, and it's actually 18 milliamps above. So yeah, precision is not immaculate, right? But it is still, I would say, more than adequate. And what you can also do with this, right, is press the set button, and you have the watts, which is again close, right? No, I think it does actually compute it. So it does have 5 volts, and it could, right, actually have 5 volts by the time it passes through this connector, especially at 2 amps, right? So let's actually go do something a bit more decent. Let's do 500 milliamps. And the fan keeps going, right? So it might have some temperature control or some logic inside that expects it to be hot. It does stop, all right. So 500 milliamps, quite steady again. Let's see, 2.5 watts, and it is again a bit. Actually, it's not shy because should be 2.6, but again, right, you're not looking at like ridiculous amounts of precision. And 5.1 it does detect. There is, however, a problem with this, right? And that is the following. So let me show you. Again, right, it's not a problem. You just have to take it with a grain of salt, right? These the readings on this, right? So this really should not substitute having one of these, right? So this one in particular is quite expensive. It's $50, but you can actually get one from the same company, right? You can actually buy them as a kit, which I did. This is $20 or even less, I think, if you get it without the Bluetooth, which you might even get without the Bluetooth. I don't know. You can only use it with Android phones and I think Windows, and I don't think I'll ever use it, but anyway. Yeah, so you would need one of these, right? If you want to do like proper stuff with this, right? Do not get one of these thinking that it will replace one of these, right? And the reason why is the following. So I'm gonna plug this in and then actually make myself a little adapter. And let's plug it in. And this is a weak ass charger, right? Which is why I love it, right? I charge these batteries with it, and even this one, and just like very slowly charges them. So make sure they're really nice and charged and also not at all stressed while it's happening. So let's plug it in. And you can already see the voltage is rather low for, I think this draws, what does it draw? Oh, I can do it like this. So this draws, let's actually measure this right quick. So 22 milliamps, right? So for 22 milliamps of a load, you really would expect more than 4.8 volts, but it is what it is. All right, so we plug this in, and we put some load on it, right? We go up to 60 milliamps, 600 milliamps, and you can see the voltage has plummeted massively, and it is also oscillating quite dangerously. Let's slow it down. Why is it doing that? Alright, so 60. And you can see already at 3 volts, right? And these are definitely not rated for that, right? You can see at 3 volts, it's reporting 630 milliamps, and it's actually drawing only 600 because this is as much as this load will, this power supply will put out. And yeah, so for example, you can tell it 800 milliamps, and it's not going to do it, right? So it's actually not drawing that because the voltage has dropped way too low for that, right? So these can't clamp the input enough, right? And also don't want to because they still need enough voltage to power the microcontroller. So these values are only guaranteed when you have like a proper supply voltage, right, of 5 volts, right? So take them with a grain of salt, right? It says 2.7 amps, 2.7 watts, and it's actually 1.7, and the shit is flickering as crazy. 3.4 volts, it's actually 2.7, right? So do not take this to its extreme, right? So you would be tempted, right, to plug it in directly, which I did, and write 800 milliamps, and you think, is it really 800 milliamps, right? And it's flickering and shit, and really not nice, right? So, but yeah, okay. So that covers the display, covers the operation, so digitally controlled. What else could I say? Perhaps the only thing missing from it would be one of those connectors where you can stick your own two wires, but that is very easy to create, right? Just get, you can get like these female connectors from China. These would be like $2 for like 5 or some shit like that. And they are very nice. They're very solid. I have glued this one together with epoxy because, yeah, I've done some pretty aggressive modifications to it on the inside, but they're pretty good, right? And they feel really good as well, right? So. And yeah, so I think that's a wrap for the review on this load. I very much fancy it. I'll be using it industrially, so can only recommend it. Have a good one, guys.